welcome to the third video on the sequence involving polymorphism. And I'm going to continue this video series by saying, well, what's the next thing that we can do to improve this program? And we can improve this program by not allowing pets to be created. This should not be allowed. Okay? And we can tell the compiler force us to not do this. It's always best to have the compiler check our work and prevent us from doing damage in our code. Okay, let's go back to the hierarchy. This is the hierarchy. At this point, you're sick of looking at it, I'm sure. But this pet should not be created because when if I have a classroom of 20 students, everybody has their own idea what a pet is. Some people think they're dogs, and even dogs can be categorized as hunting dogs, toy dogs. Let's see, there's other types of terrier dogs. They can also be subclasses of this dog. They're all dogs, and they all behave like dogs, but they look different in one way, in some way or another. So we can put other subclasses down here. And so, I use the word subclass, and that's an important term. See, I've been using parent class and child class. This is the parent, this is the child. A lot of books use the concept of superclass and subclass. Base class, derived class, they all mean the same thing. The parent can be considered the superclass, could be considered the base class. The child classes can be considered derived classes. They can be considered subclasses as well. They all mean the same thing depending upon the book that you have. So you decide which one you want to use in terms of definition. Let's take a look at how we can tell the compiler not to create pets. Here's what you do. Define the class pet to be abstract. Define it to be abstract. And a pet is sort of an abstraction, and we don't need this extends object. That's extra code. Okay, because everything is as an object anyway, unless you explicitly say extends pet. Now, this prevents us from creating a pet. And if you can't create a pet, then hey, can't get rid of this. Let's put something in its place. Let's put a new big bird. Big bird in its place. Alright, so now we can't create pets, which is a good thing. And in terms of abstraction, you don't really need, since we can't create these pets, this code here isn't really needed. Any of this code really isn't needed at all. This code, pet. I'm going to leave these two other guys alone. I'm not going to touch those. But this code, since you can't create an object of type pet, this code will never execute. So let's go ahead and say, well, at runtime, will never execute. Let's put a semicolon there. Okay, and that semicolon says, all I'm doing is I'm defining what a pet can do, but I'm not defining how to do it. When you put braces in there, you're defining how to do it. And this is going to be another semicolon there that says, these two methods, I'm describing what pets can do. There's no need to put define a body, because that body can never execute, because you can't go, remember at runtime, you have to actually go to the object, and from that object, the system looks at what the kind of object you have and executes the code from there. Since you can't create pets, you can't execute that code. But what you can do is describe what pets can do. And then as soon as you put the semicolon here, you need to make sure, and you see there's an error there obviously, you need to define that method as being abstract as well, so that error goes away. And it's not enough to say that, okay? If you have an abstract method, you have to define the methods themselves as abstract, okay? And the class has to, if you have any abstract methods, then the class has to be defined as abstract. So you're going to be using the word abstract a lot. Okay, and the errors goes away. But that's not to say you can't define some methods, concrete methods, that inherit. So what I'm going to do is I'm going to say, well, I can't create any pets because I have a couple of abstract methods and the class is therefore abstract. But I am going to provide methods that other people can use in my hierarchy. I can provide a method that takes a generic pet. It's defined here, so dogs, cats, birds, and big birds will inherit that method, as well as a method that takes a bird. They're two different methods because they're two different classes here. So those classes will inherit. Okay, inherit those methods. So all we have to do, as soon as you have this abstract class pet, class snake has to implement all the abstract methods if you intend to make a snake. Let's pretend I didn't do this. Let's make this. Let's comment this out. I'm going to comment the speak method. See, the problem here is this. I extend pet. Pet is abstract, which forces me to have to implement the what am I method and the speak method, but I didn't do the speak method. So if I hover over this method, this thing must implement the inherited abstract method if I want to create a new snake. Hey, so right now, in order to get rid of this error, I have to declare this class to be abstract to get rid of the error, but I can't create a snake because it's an abstract class. So it just bubbles up. The problems bubble up. Now what happens is, if I do override all the methods that this pet class tells me I should override, I can remove the abstract class here, and now I can create the snake the way it works. The actual operation, whether I have abstract methods or not, is the same. Okay, at compile time, is there a method called what am I that I can apply to a pet? Sure. It's abstract. That's so good. All that tells me is I'm going to have a child class that's going to implement that class. That's all it says. Same thing with the speak. All right, and that's a good way to prevent you from creating pets. So let's see if this works. Okay, it looks like it's working. A lot of birds. It takes a lot of birds because 50% of the time, okay, you're going to have a bunch of birds. So let's go ahead and, yeah, that's a better distribution. Okay, so I'm getting the same output. And every time I have a dog, it says I have my barking dog there. So I think this is working pretty well. So I think abstract is not really a hard concept to understand. An abstract class generally will have abstract methods, although not necessarily. But if you do have an abstract method, the class has to be marked as abstract. You cannot create any class that's ultimately abstract. You can't say new pet because it's abstract. You need to create another class that implements these methods. Then you can create an instance of that snake. So the idea being, at the very top of the hierarchy, you're supposed to sit there and say, what do all forces? It basically forces you to outline your code. At the top, what do all classes of type pets do? Sit there, think about it, but don't force. Okay, all animals eat, but they eat in different ways. Dogs wolf down their food. Birds peck away at their food. They all do different things. But they do, so abstractly, eating is something that's shared by everything. But the actual implementation depends upon the actual object that you're trying to mimic. And so that's why it's forcing you to have to create a class that implements those methods. All right, we'll see you in the next video. I think there's just going to be one more video on polymorphism and inheritance. Okay, we'll see you then. Bye.